Okay, so I don't know if you guys have been to the other MRF lectures. I know Megan did one, but this one is intended to be more of like a hands-on intro to using R in epi analyses. My roommate's cat is trying to get in my room. So I'm a data analyst in Kristen's lab in the MRF group. And I do feel a little nervous about teaching this lecture because I feel like I'm new to R and I don't know everything. You know, I Google a lot of things, but I also thought it was important that I do this because I want to impart to you all that you don't need to know everything to use R, that it's like a really, really helpful tool. And most everyone who uses it is Googling stuff 95% of the time. So like you can just get your feet wet and use it, get used to it, and then like build your skills up as you go, but you don't need to be an expert right away. And I think it's cool that we can all like be together in this group because maybe in the future we could have like a Slack channel or something where we can use each other as like support if we have like our questions. But yeah, so feel free to like interject and ask any questions you have throughout the lecture, but I honestly might not know the answer, so we might need to Google it together. And yeah, so this is like, I called it like intro to epi analysis. So we usually think of epidemiology as like the study of disease, but of course we know autism isn't a disease, it's a neurotype, but we can still use epidemiological methods to try to understand the basis of autism and beyond that, brain development in general. And you've probably gathered from like the other MRF lectures that our lab is specifically interested in looking at environmental factors and how they relate to autism. So for today's workshop, I attempted to simulate a data set that's very similar to one data set we use a lot in our group. It's called the early data set, and it followed a group of pregnant people who had a child, previously had a child who had autism. So we say that they have, there's like an increased probability that their next child will also have autism. So in this study, they gathered like so much information about the pregnant people, like went to their homes and did like dust samples, collected like blood and urine. Yeah, gave them like multiple interviews, took like dietary questionnaires to figure out what they're eating. So there's like a ton of data about many different environmental aspects. And I can share the data set we're going to be looking at. Was everyone able to download the files I sent a few hours ago? There's like a, let me just share it. Okay, can you see this? Yes. So yeah, it's just a set of variables, and I'm going to show you the code book because that's easier to understand what's going on. But essentially the main outcome that we tend to look at with this early study is, oh, hi Diana. Can you hear us? Hi.
Yeah, sorry I joined late. I couldn't find the Zoom link, but Nate sent it to me. So.
Oh, sorry, it was a secret Zoom link I only sent to registers. People who registered.
Well, I just registered this moment ago, so.
Well, welcome. So I was just telling everyone that I made a simulated data set that's similar to our early data set. So none of this data is real. We don't have to worry about IRB stuff. So, but essentially in your data set, you'll see these two variables, which are like our main outcomes. So SRS refers to the social responsiveness scale. And that's a continuous measure that gives each child a score ranging from 0 to 195. And it assesses like social communication, restricted repetitive behaviors, etc. And we know that higher scores, like scores above 60, tend to be associated with an autism diagnosis. And then we also have a categorical measure of autism, which is autism diagnosis, yes or no. And you all might already know this, but well, you probably already know this, but continuous measures are like numerical. They can take any value between like a set, min, and max. Categorical have categories. So you'll see in this column here for values, there's like 2 possible categories for autism. You can either have it or you don't have it. And then similarly for these variables down here, which are going to be our covariates, they're other variables that we're interested in. They have other categories. So you can either take prenatal vitamins or not take them when you're pregnant. You can have an income that's 50K or less, between 50K to 100K or more than 100K. And that's just going to come up when we're coding in R. So I just want to make sure we all can see the differences between continuous and categorical. And so then also in this data set, we have a ton of variables that we might be interested in. So these are different aspects of the environment that we collected data on in early. So here we have the alternative healthy eating index for pregnancy score. And that's basically a measure that like takes all the dietary data of these parents and then like scores how healthy their eating is based on recommendations for pregnancy. So a higher score is a healthier diet. Then we have the residue burden score, which like shows how much pesticides people are getting exposed to in their diet. We have like fruit consumption, veggie consumption, and then we have things like amount of thyroid stimulating hormone, which is a hormone that's released when your thyroid hormone levels are lower. And we also have like this measure of oxidative stress. And we don't really need to go in depth about what these variables are right now, but for your independent projects, you're going to be picking one of these variables that you want to look at. But for today, we're just going to look at fruit consumption mostly, because that's very easy to wrap our heads around. So let's see what's in. Okay, so now I'm going to move to R. And was everyone able to successfully download it? Cool. If not, like we can work on that after this lecture. And you don't need to use R right now, but it might be nice if you want to open R and like run the code while you're watching me run the code, because everything should work for you. So basically you see there's like 4 main windows in R. This one on the top left is our script editor. And I opened that document that I sent you. That's our workshop part 1 2022.r. That's an R script. So this is our code that we're going to be running today. Then in the bottom left, you see the console. This is where we're going to see the results of everything that we run. So if I put like, I wrote in my script like 7 + 5 and run it, then I'm going to see the answer down here in the console. And then in the top right is our environment. And this is going to keep track of like the variables that we make. So we'll be able to see a list and some information about that. And then at the bottom, this is like the output. So if we make any plots, they're going to come here, show up here. And then like if I look at a help file, that would also be here. Okay, so I feel like when I first looked at our script, I was like, ew, what's happening? It's so crowded. And why is some of it green and some of it black and blue? And essentially, like everything that's in green is just a comment. And it turns green because I put a hashtag in front of it. So if I delete this, it's black. But if I put the hashtag up, it turns green. And the commenting is like a skill you want to develop as you go, because if I just like write the script without any comments and I try to share it with a collaborator, they're not going to know why I did what I did. And they might be very confused by my code. But if I like comment throughout about like what my intentions are, like why I'm doing this thing, it's a lot easier for other people to read. And if I come back to my code like 2 years later, I'll remember what I was doing too and what I was thinking. So anything in green is just like me offering too much commentary on what's happening. So everything that's in black and blue are like actual commands that we're sending to R. Okay, so we're gonna get started. If I know like in the instructions for downloading, I said like you should make a file path on your computer where you're gonna put the files. So if you could put the dataset file in there, then we're gonna refer to that later. So you just wanna know like where you have it saved on your computer. So the very first thing we're gonna do in R is install packages. And packages are essentially like toolboxes that have different functions for different things you want to do in R. So we're going to install this package called Read Excel. That's going to let us import Excel files. Then we have this other package, which is actually a collection of packages called Tidyverse. And this one is like very commonly used and very, very, very helpful. It has like tools for making visualizations, for cleaning your data, manipulating your data. So that's like a main one you want to do. And then this one is another one I just found called Skim R, and it's useful for like descriptive statistics. So essentially you're just going to highlight these things and hit run. And I've already had these installed, so I'm installing them again. But in R, like you only have to run the install packages command once ever, and then it's saved on your computer. Okay. There's always lots of red text in this, but it's chill. It's not telling me anything bad. Okay. And then after we've installed them, we have to load them. So this here is where I like tell R, load this package, I want to use it. And you're going to have to do that every time you open your R script, because R is not going to load everything you've ever installed all at once. So I'm just going to run this. Okay, and you'll see this warning, like package read Excel was built under R version 4.1.3. Actually, all of them were. So I think that's because I have the most recent version of R installed, and not all the packages have been updated. And I haven't found too many issues with that running this code today, but that might, like, if you install some package that hasn't been updated in a while, you might find it doesn't work. And you might have to install like an earlier version of R, or you might be able to find another package that can do the same thing. But yeah, I'll come back to that later because I did notice one issue with one of these. So next we're going to set our working directory. And this you want to do like every time you're running a code, because it tells, you're telling R where to look for files. And just makes it a lot easier, so you don't have to like write out the whole file path every time you want to import or export something. You're just like working in that one folder. So if everyone wants to make note of the file path for your documents and then just paste that inside the quotation marks here. And you'll notice that in R, it only recognizes backslashes that are going to the right. I don't know if that's how you describe this backslash. This is always annoying to me because SAS uses backslashes the other way. But just, it might give you an error if your backslashes are going the other direction and you just have to switch them. So I'm gonna run this and all looks good. You can see the command down here that I just ran and no error messages came up. And then the next step is to import the data set. So this syntax means that I'm making a new data set that I'm calling D1, a data frame. And I'm using this function called read Excel. And that's actually from that package we installed called read Excel. And I'm telling it that the Excel sheet I want is called this. And that should be the name of the one you have too. So I'm just gonna run this. Oh no, it's mad at me. Oh, it's mad at me because I have the data set open and I have to close it before I import it. Okay, that worked. Is everyone following along so far? Just let me know if you have questions. Okay, so the first thing we want to do is get a sense of our data set. So I like to use this command, view, because it opens the data set in a new tab and it's just a lot easier to look at and you can scroll. The weird thing about that though is that view is a capital V. I just find that weird because every other command I've seen in R is lowercase. So just keep that in mind if you're ever confused why view isn't working. We can also run this command dim, which is going to show the dimensions of our table. So this is saying there's 154 rows and 19 columns, so 19 variables and 154 observations. So that's each different pregnant person. And then we're going to get into summary stats. So there's this nice function called summary. which I'm going to make this bigger. So it essentially just shows you information about all the variables. So I can see, like, for SRS, my minimum value is 0, my max is 83, the mean is 39. It also gives you the first and third quartiles and the median. But I'm wondering, does anyone notice something funny about these results? There's actually two funny things.
It does continuous outcomes for categorical variables.
Yes. Yeah, I was like so frustrated this morning trying to fix that aspect. But found this function class, which will tell you like the class of your variable. So this is saying that my variable is numeric, my ASD diagnosis variable, and that's not what I want because I have two categories, 0 and 1, and I don't want SAS to treat that like a continuous, R to treat that like a continuous variable. So I found this function that will let me recategorize it as a categorical variable. And essentially what this is saying is, look at data frame called D1, then this like $sign tells it which column to go to. So I'm going to the column called ASD, and then I'm saying recreate this column as a factor. So I'm gonna run this. And now when I say class ASD, it's gonna tell me factor. So I successfully created a categorical variable. And then I have to do that for my other categorical variables, which are like prenatal vitamins, income, and smoking. Should be all good. So now when I run summary, yay. So our categorical variables, now we can see the N for each category. Okay, so does anyone notice anything else funny about this data set?
I have another. There's some negative values.
Yes. So you'll notice there's like negative fruit intake as the minimum. And actually that's just a me problem. I was trying to make a simulated data set and I couldn't figure out how to set the min and max. So some of these variables are just a little bit funny, but we should still be able to do our analyses today. Just keep in mind, it's not the most realistic that you'd be eating negative fruit. Yeah, so then I found this other function called skim, which also gives some nice summaries. Yeah, you can see all my negative percentile values. But this tells you like how many are missing, how many values are missing, which is really helpful. Luckily, we don't have any missing. And it also gives you standard deviation, which summary doesn't give you. Yeah, that's basically it. It's also supposed to show you like a tiny little histogram that shows like a frequency of your values over here. But I'm wondering, it's not working for me, and I'm wondering if that's because of that warning message I got where like this package was made for an earlier version of R, or it might just be some other issue. I didn't Google it yet.
It's showing up on mine. I don't know.
Cool. So you see the little histograms?
Yeah, they're cute.
Oh my gosh, cute. Okay. So our next step, the next step is just to look at the distributions in more detail. So we're going to make histograms, which show us the frequency of variables in our data set. So we're going to use this package called Ggplot, which is really commonly used for visualizations in R. So you'll see here I'm saying I want to use Ggplot. I want to use my data set called D1. And then here you add geom histogram. So that's saying make a histogram. And then you have this funny little phrase AES, and then X equals fruit. And that's basically just saying my X variable is my fruit variable. So I'm going to run this. Ooh, wow. Okay, so we got this histogram and it looks pretty normally distributed, which is good. That makes things easier for us. But you do see this warning here, like stat bin using bins equals 30, pick better value with bin width. So that's saying like the default is that it's going to pick 30 like bins for my histogram. And I can easily change that myself if I want to make more bins. So here I set it to 60 and just looks a bit better. So you can play with those settings and adjust it for your variables. And then I'm also going to take a look at my outcome variable, and I'm using SRS score. And that's like pretty close to normally distributed. Looks good enough for me. And then we're going to go through some more visualizations. So first, we're going to start with a bar chart. And these are helpful when you have a categorical variable that you're interested in. So we're going to look at ASD diagnosis. And it's really similar syntax to what we had above, except now we're calling geome bar instead of geome histogram. And so you'll see there's like 120 people that don't have autism, something like 24 that have autism. And if we want to make this look a little bit better, we can add this phrase here, fill equals ASD. And then we like color code it based on the category. And I do want to talk a little bit about this phrase AES. So essentially anything that you put in here in these parentheses is some aspect of your plot that is defined by your data set. So because I want the color to be based on my variable ASD, I put that inside the parentheses here. But if I just wanted like my plot to be blue and it didn't have anything to do with the data, I would put that outside of AES. So here I just said fill is blue. Yeah, it looks like that. So that's just a helpful thing to know. Okay, then we can make a box plot, and here, oh, that's useful when you have a continuous variable and a categorical variable. So I'm looking at income, and we have 3 income levels. I think this is less than 50K, 50 to 100K, and over 100K. And box plots are really cool because they give you a ton of information. The median here is this horizontal line, and then you have your min and your max in your first quartile and your third quartile. And if my data set had outliers, I'd be able to see them at the edges, but I don't have any outliers for this plot at least. And then we can make it look a little better by adding some color with our, where did I put my color phrase? Oh yeah, fill equals income inside the AES because I want it color coded by the variable. And then I added some like specifications for the outliers, but you can't see that because I don't have any outliers here. And then I added this phrase, notch equals true. And I actually just learned about this today, but it's pretty cool. The notch actually indicates like the confidence interval around your median. And I was reading that you can essentially tell if the medians differ significantly by whether or not the notches overlap. So here my notches all overlap, so there's not a significant difference between my medians and these 3 income levels. But that's just a cool feature.
That's super cool.
Yeah. And then lastly, we're going to make a scatter plot. So this is for 2 continuous variables. So I'm going to use my fruit variable on the x-axis and my SRS score on the y-axis. And looking at this plot, I don't know, do you guys think that it looks like there's a relationship between these 2 variables? You can just nod or shake your head. See, iffy, no. Okay, well, that's what we're going to figure out. Is there a relationship? First, I'm going to make it look a little better by adding some color by income, just for fun. Even though we know income's not really at play here. I also gave you some code to make different facets. I think this is fun. You can essentially like make several mini plots based on a categorical variable. So I added this phrase, facet wrap, funny squiggly. I don't know why it uses that syntax. Income, and then the number of rows is just saying like how many rows I want it in the display. So this looks like this. So I could separate a separate plot for each income level. And also just to note, when you're adding phrases onto your Ggplot command, you want to put these little pluses at the end of each line so it knows to keep looking. And then I can add a regression line. So, oh, okay, good, it works. So now what do you think? Now do you think maybe there's a relationship between these variables? Maybe, or it's just fitting a line. But so this is, okay, well, first we're gonna make it look a little better. So this code looks a little more like a headache, but if we split it up, it will make sense. So we're doing our scatter plot, we're adding our line, and then we're gonna add like labels to our X and Y axes. We're gonna change like the scale of the Y axis so you can play with that based on your data. We're gonna add a title, and then this stuff like the theme. Oh, I have the same thing twice. I don't need that. The theme just like messes with how the plot looks overall. So black and white, I think, gets rid of like this gray background if you don't want the gray background. And this part here, plot title equals element text h just equals 0.5 is basically just saying center the title. And all of this stuff, like, I never remember this off the top of my head. I just like Google it every time, or I'll use old code. So you don't have to know this. You don't have to memorize this syntax. Okay. Uh-oh, it didn't center my title. Well, I'll figure that out later. And then there's this other cool thing I found that's you can like install themes for your Ggplot. So if you install this package here called ggthemes and then load it, also built for earlier version of R, you can like apply the theme here, theme economist. So that's one of the themes in this package, and it makes your plots look like they're from The Economist. So nice. Yeah, so you can explore all the different themes in that package. Okay, so now we're going to investigate, is there actually a relationship between fruit and SRS score? Is this significant? And we're going to do that with a linear regression. So that basically fits a straight line to our data set to describe whether or not there's a relationship between our independent variable and our dependent variable. And the way you do that is with this really simple line of code. So first I'm going to start with my simple linear regression. I'm just going to have the dependent variable and the independent variable. And I'm calling mine linear regression C for crude, meaning that there's no covariates. And then you call LM, that's the linear model function. You put your dependent variable here, which is my SRS score, little squiggly, and then your independent variable, which is fruit intake, and you tell it to look at data set D1. Okay, so that worked. And then if I want to look at the results, I say summary, and then I call the name of that model as I saved it. Okay, so if you look down here, you see what you called, what you told R to do. You have your residuals, which I'm not going to go into right now. And then you see the results of your linear regression. So you can see the estimate for the y-intercept, and then for your independent variable, which is fruit. And this shows you the standard error in that estimate. This shows you the t-score, that's what it's called. And then this shows you the p-value. It's like a very funny label, but this is p-value. And then here you have these little asterisks that tell you what level of significance it is, and you can tell based on the code here. So we have 3 stars, so our significance, I think this is rounding, but it's like 0.0001. So very significant relationship. And the way we would interpret this, because it's -7, we'd say that for every unit increase in fruit consumption, there's a 7-unit decrease in SRS score. So that's like pretty wild. That's like a big jump in SRS score, but keep in mind that I made up this data, so that's not real. Yeah, so Next, we might want to kind of make our model more precise by adding in covariates. So these are other factors that might be confounding or might be related to the outcome. So we know that maternal BMI and maternal age do have some relationships with autism. So we're going to add those into our model. So this is my linear regression adjusted, A for adjusted, and I just added my covariates with plus signs. And now let me look at my results. Okay, so we see that fruit still is significant in this model. It's like slightly lower in the estimate. And we also see that BMI seems to have a significant effect, but not maternal age. So that's interesting. And then as a added bonus, I was struggling with this morning too, adding a categorical covariate. I was having some issues, which I'll show you now. But essentially with a categorical covariate, you don't want it to be treated as like continuous in your model. You want R to understand that there's like 3 categories, and one of those categories is going to be your referent. So kind of what you're comparing to. And so if I run this straight where I just added income on the end, you'll see that it's made dummy variables for me. And I was confused by dummy variables. Maybe you guys have done this before, but it's essentially where you like take your categorical variable and you make a new variable for every category that's binary. So this is essentially making a new variable called income 2, and it's only referring to income level 2, which is like 50 to 100K, and it assigns everyone a 0 or 1 if they're in that category. And then it does the same thing for income level 3. So 0, 1 if you're in income level 3 or not. And it also did that for income level 1, but it's using that as the referent in this model. So it's not including it as a covariate in the model because it's what we're referring to. However, when I look at my data set, I see that the most common income level is actually income level 3, not 1. So I want to use income level 3 as the referent, but R doesn't know that. So I have to essentially tell R what level of the categorical variable I want to be the referent. So that's what I'm doing here. I'm saying for the income variable, I want to give it levels, I guess, levels to the categories. And I'm going to say the referent is 3. So now when I run this, you'll see that I have income 1 and income 2 in my model, which is great because that means income 3 is the referent. Did that make any sense, or did I just say a lot of confusing things? You feel okay? Okay. Okay, and then I think we have time to look at the logistic regression. So this is similar to linear regression, but it's when your outcome is binary. So if we're looking at ASD diagnosis, we only have 2 categories. You either have it or you don't. So yeah, essentially same situation. I'm not sure what R assumes the referent is for logistic regressions. I don't know if it would assume that my 0 value or my 1 value is the referent. I'm pretty sure it knows to do 0, but just to be safe, I decided to assign the referent for my ASD variable. So similar to what we did above, I said my reference is 0, which is no autism because most of the data set has no autism. And then I'm going to run this code, which is really similar to above, but it's GLM instead of LM. And I want to specify family is binomial. Okay, so interestingly, now we see the relationship between fruit and ASD diagnosis is not significant. I think this, yeah, p-value is 0.07. So that's just interesting that there's a difference between diagnosis and SRS score. And then I can adjust this as well. So interestingly, BMI still has a significant relationship with ASD diagnosis. And then if I want to add in that income variable, I can look at that too. But yeah, not a significant relationship. So I think that's essentially all I had. And I'm wondering if you guys have anything you have questions about or other things you'd like to know that we can go into. No pressure. If not, we can move into like the independent project assignment. That's cool. Thank you guys so much for coming to this. And
well, thank you for doing this. It's fun, actually.
Yeah, it's really fun. And literally email me any questions you have and we'll figure it out.
Cool.